In the previous video, I left off with this picture here, illustrating the idea of the Pigovian tax, and what it does is it gets each of the firms to reduce its emissions while taking into account that the different firms have different costs of reducing emissions. And so, as a society, we'd like to minimize those total costs. There's another way of attaining that, and that is called capping emissions. You can see that what this Pigovian tax does is it produces a certain total amount of emissions. Firm B emits more than firm A because it faces higher costs of emissions reductions. So what would happen if we capped emissions, if we said we're going to allow a certain total amount of pollution, or emissions in other words, and to emit some pollution you need a permit. So what we could do is say we're going to issue a total number of permits reflecting the total amount of emissions that we're going to allow, and we'll auction those permits off to the different firms. How much would firm A be willing to pay, and how much would firm B be willing to pay? What would be the price of an emissions permit? Well, I'm going to suppose in this example that I'm issuing exactly the amount of permits that was the amount of emissions in that previous picture here with the Pigovian tax. So where would demand and supply be equal? I should just add that this story is not in the text, but kind of important to understand it. And the argument is fairly simple. You can see that if this is the emissions permit price, we have in effect the same story as we saw in the previous slide. Firm B would like to buy this amount of emissions permits at that price rather than pay the higher cost of reducing emissions. Firm A, on the other hand, if that was the emissions permit price, would be willing to buy only this amount because it can reduce its emissions relatively more cheaply than firm B. So in this case, the supply of emissions, the total number of permits, is the amount bought by firm A plus the amount bought by firm B. That's going to be equal to the total amount that they would like to demand. So supply is equal to demand at that price. I've sort of constructed it so it works that way. So this is really an argument that says, in a way, the Pigovian tax and emissions permits are two sides of the same coin. So, in other words, they potentially have the same effect. In practice, they're a little bit different because when, in this case, you issue a certain number of permits, you know what total emissions are going to be. What you don't know is what they're going to sell for. In the previous case, when we looked at the Pigovian tax, you know what the tax rate is going to be because that's what you set, but you're unsure about how people are going to react to it. So, in principle, they're two sides of the same coin, but the choice may make some difference. Well, I'm just going to give you a practical example of a situation of a positive externality. So far, I've been talking about negative externalities and pollution and bad stuff like that. But let's end on a positive note here. So one interesting business that I was reading about recently is kelp farming. So this is a picture of a kelp farm. Now kelp is this illustrated here. It's an edible seaweed. You dry it out, process it, and can eat it. It's nutritious. And you can grow it relatively cheaply using a setup like this. So it doesn't take a lot of money to set up a kelp farm. You need a boat like this, and you need some basic equipment. Why is there a positive externality here? Well, what's been going on with climate change is that as carbon dioxide has been emitted into the air, as fossil fuel is burned, the oceans have been absorbing a lot of that. And the basic chemistry of that is that when oceans absorb carbon dioxide, they become slightly more acidic or less basic than they otherwise would be. In other words, the measure of acidity is pH. The pH of the oceans has been changing, and fairly significantly, actually. The oceans have also been, as I note here, absorbing more heat, which contributes to more severe storms. So what, of course, if you grow plants in the ocean, that's going to help to absorb that carbon dioxide. And by doing so, that's going to make the surrounding water less acidic than it otherwise would be. And it turns out that the greater the acidity of seawater, the more difficult it is for shellfish to produce their shells. So what you can do is combine kelp farming with producing mussels and scallops and oysters, all shellfish. And the combination of all of these things can produce a decent income for the farmer who's running this farm in the ocean. It also has a further positive externality in that if a storm comes along, there's going to be friction as the water moves through these kelp forests. And so that's going to reduce damage from storm surges along the coast. So all of these things, all of this activity involves positive externalities. So these are externalities which the kelp farmer wouldn't necessarily take into account in deciding whether or not to set up this business. So let's consider a brief theoretical analysis of positive externalities. It's really just a variation of the ideas that we've seen before. So in this particular situation, if people in this market are simply considering their private benefits and their private costs, in this case, there are benefits, these external benefits that I've described of carbon dioxide absorption and the effects, lessening the effects of storms that are not being taken into account. In other words, there's a marginal external benefit that comes from producing this last ton of kelp, let's say. So I've illustrated that benefit by this red arrow here, the height of that arrow indicating the external benefit in dollars of producing this last unit. So if we want to think about the marginal social benefits of this activity, we have to add to the marginal private benefits the external benefits that are generated. Well, that's going to tell us that this market is inefficient, because in the situation where the market has ended up, the marginal external benefits are greater than the marginal social costs, as reflected by this black line. Well, that tells us we should be producing more of these goods that are providing these positive external benefits. How big are those positive external benefits? Well, what we need to do is just compare the extra benefits that we get as a society by producing more of this with the extra costs that we incur. And you can see that for every unit between here and here, there's an excess of benefits over costs. So if I just add those up, that shows the extra benefits that we're going to be getting if we produce extra amounts of this product up to this point. Of course, beyond that point, the marginal social costs would be greater than the marginal social benefits. So that triangle there shows the surplus that we're missing out if we don't produce more of this good. Clearly, what's needed in this situation is the opposite of a Pigovian tax. We need a Pigovian subsidy. So what we need to do is to encourage more of this activity, because if people are just left on their own to make their decisions, as we've seen, there won't be enough of it. So let's see what that subsidy would look like. We want to choose the right subsidy so that the subsidy that we're offering to producers is just equal to the marginal external benefit that they provide. So we want, in other words, to get a new efficient equilibrium, and that's going to be where marginal social benefits are equal to marginal social costs. Let me see if I can get my laser pointer so I can point to that spot. So we want to end up in this situation, and what we're going to do is lower the costs of suppliers by this amount so that they're willing to supply buyers at this lower price. So what we're doing for the buyers is we're lowering the price so that they're going to be willing to buy more. And the resulting marginal social benefits are going to be equal to the marginal social costs. So let me just summarize where we've been. We've seen that there are externalities, important ones, both positive and negative, and if we don't do anything about that, that's going to lead to an inefficient use of resources, at least in the situation where there are no other things influencing our competitive market. There are more complicated situations we could consider, but we'll leave those for some future course. I wanted to emphasize that externalities are really important, and they're everywhere if you think about it. Even, for example, staying at home and preventing yourself from getting this virus that's circulating around is providing an external benefit to other people. Because if you don't get the virus, then you can't pass it on to other people. There's also an external benefit for a person who is perhaps feeling sick to be tested for the virus. And that test is going to provide other people with a benefit, because then medical authorities would know whether that person is sick or not, and they could take appropriate measures to prevent that person from passing on the disease. So what we've seen is that a Pigovian tax in a situation where we've got a negative externality or a Pigovian subsidy could be appropriate to correct the problem. Now, I've kind of slid over issues of whether governments have enough information to be able to choose an appropriate tax or subsidy. I've not discussed in any detail administrative costs, although I did mention, for example, the difficulty of monitoring pollution. Well, I gave you many examples of especially negative externalities where there was clearly still a big problem. And it seems that governments are not acting in many cases in an appropriate way to correct these externalities. So I would just emphasize that these Pigovian taxes or subsidies are ultimately a political decision. So certain interests are going to be at play who might favor those taxes and subsidies or who might oppose them. And we will certainly see that in the future when I consider the case of the carbon tax.